Okay. Let me ask you one question. Since I'm working with the hypothesis testing for all the coefficients, okay? So remember, the statement I do is, so for the first one, this is my null hypothesis, this is my alternative hypothesis. But by theory, I know that the more competitors, the less the business, right? So my purpose is decided whether beta 1 less than 0. And we compare with the 0 is because if I less than 0 means the sign will be negative. If greater than 0, the sign will be positive. So I don't care really the real beta is. I just care whether it is negative relationship and a positive relationship. Okay? You know, especially all of you, if you are a new learner of the hypothesis testing, I think you will have some kind of questions in mind. The first one will be, since I'm working with the first one, right? Wow, this number is negative 9074 something. It's so huge from 0. So can I just look at all this coefficient to determine whether it is negative relationship or positive relationship? Can I? Or it is reasonable to just look at those numbers. Look at these numbers, negative 9074. It's so far away from 0, which is so far it's really, really negative. Do you have this kind of questions in your mind? Do you? Not really. Why?
If the x standard unity we use is 1, so it means that for n, p, and I we use 1. Well, it actually depends on the x, because if, well, for instance, p, the x we're gonna get in the equation is like 3 million, of course it's gonna overcompensate for the big coefficient of n.
Okay, so do you mean the measurement units?
Yeah, the measurement.
Okay, the measurement units determine the size of the coefficient, right? You know, I always mention that because it is very, very important. You know, the size of the coefficient, when I say the size, or maybe I should say the magnitude. The magnitude means the value of this coefficient really determined by measurement units. Remember that if I change my measurement units from dollars to $1,000, then the coefficient change, right? Therefore, do not just look at all this coefficient to see whether it is really negative or positive. Because the coefficient can be changed by the different measurement units. And what matters to determine positive sign or negative sign, or maybe what values determines reject the null hypothesis or do not reject the null hypothesis, is the test statistic. Did you see those test statistic? It's using the coefficient divided by standard error. And the t-test, t-statistic, is already, there's no measurement units for t-test. What's the measurement units here? Is there any measurement unit in the beta? Yes, yes. because it's determined by the measurement units. And the standard error is also determined by measurement units. After they divided, all the measurement units canceled, right? So this one, we don't have any measurement units. Therefore, we can using these numbers to compare each other. You see what I'm saying here? You see what I'm saying here? This is key. This is very important concept. So we are always using this test statistic in order to compare the critical values. And which critical values is determined by the alpha of significance level. The level of significance, or we say significance level. Okay, these are the keys. Okay, so this is working with the individual beta. Okay, I'd like to all of you download from our iLearnings. Okay, maybe you have to download all this data set. Okay, from the chapter 3. And the data file is Scratch. You know what I'm saying here? Let me see. I need to go to the iLearnings. Let me go to come to our class. I do have this data set right here. Where is it? Okay, the data set. Then I'll download it. Chapter 3. And just using eViews. iPad 3, I'm sorry. iPad 3, download this one. iPad 3, data, iPad 3. Okay? Then turn to the page of 105. The Y values will be the price. Let me just run it, okay? This is what I have, okay? If you look at chapter 3, exercise number 7, on page 105, there's a regression with price as a Y and new, scratch, and bits are the X variables. Okay? So I'm running price as a Y. New. Okay, this one. So the y variable is price. Okay. I have three x variables. If you look at the definition from page 105, price means the price at which the iPod sold on eBay. This is the auction markets price for the iPod. New means the dummy variable equal to 1 if the iPod was new. And scratch means the dummy variable equal to 1 if iPod had a minor cosmetic defect. And BIDRS is the number of the bidders on the iPod. Okay? So first of all, this is regression analysis. Okay, that's decided the relationship between all the independent variables and the y variables. Okay, first one, new. If the iPod is new, then what's the price? The relationship with the price. We're just saying positive or negative, that'll be fine. Okay? What's the relationship? Positive, right? Scratch means there's minor cosmetic, so the price will be negative. Okay, how about bidders? The more bidders, the higher the price, because there's many people want it, right? Okay, so all of them are positive. No, only one is negative. And this is the computer. This is output we're running. Okay, would you please do the hypothesis testing for the bidders? Do it now. Practice. I want all of you to do the practicing from step 1 to step 4, or even follow me as a step 5. Work it now. If you have any questions, ask now. Do birds on BIDRS only. Okay? And one thing I like to mention to all of you again, okay? I read your assignments for the previous 2. I already read it. Didn't I say that for each group, you have to turn in the individual report? Did I say that? Individual report. Okay? Do not turn in the group report. If you're a same group, just put the different names on it. And the rest of the report exactly the same. Even the computer output. Okay, do not turn in like that report. You understand what I'm saying here? Do the individual output, but do the individual report by yourself. As a group member, you can discuss each other. You can just even compare the result each other. But do not turn in exactly the same report to me. Okay? Make sure everybody understands it. I think I say it vividly and clearly at the beginning of this semester. Do you all see the third assignment is easier? Do you think it's easier? No? You don't think it's easier? I thought it's easier. Huh? You don't think so? I think we still have 3 assignments, right? These 3 assignments even complicated than the first 3. Yes. Yeah, okay. I know what you're saying. Now, how many observations do we have? 215, right? And from the tables, what do we have? Just up to 120, right? So in that case, just use 120. The 1 was 120. Okay, it won't matters that much. Okay. Whatever greater than 120, just use 120's critical value. Okay? Since it is just table, right? It will not provide us everything. Okay, but it won't matters. So do the critical value approach and also p-value approach, okay? Step by step. So the step 1, you have to state the null and alternative hypothesis. The second one, just set alpha level, whatever alpha level, you can decide it, okay? Any questions?
1%, 5%, or 10%.
Yeah, whatever, decide it by yourself, okay? You can decide it by yourself.
So should we use just one-side testing?
How do we decide one-sided test or two-sided test? No, I ask everybody. I just happen to look at you. How do we decide one-sided or two-sided test? Based on what? You all remember the 6th step for the regression analysis from chapter 3. What's the first step? Don't confuse with hypothesis, the step from hypothesis testing and the regression analysis. The first one is literature review, right? Okay, literature review. Then the second step is hypothesize the directions of the relationship. So, didn't we just say that the more readers in a theory or from your common sense, the higher the price? So it should be one-sided test. So we put the alternative hypothesis as one-sided test from the step 1. Okay? I'm glad you asked questions. I know that you should have many questions in your mind. If you don't have any questions, then I really doubt it whether you understand or not. Since we just learned in the beginning, right? Okay, so this is our step 1. Beta 3 greater than 0. and a null hypothesis will be less than 0. Okay? Okay. Step 1. What's the step 2? Now you can determine by yourself whether you want to 1%, 2%, 1%, 5%, or 10%. As long as it's less than 10%, that'll be fine. Okay, you decide it by yourself. So here, we say that 1%, 5%, and 10%. So now the step 3 is collect the data and calculate the statistic. We can get the test statistic from output, or we can, using the numbers and divide it by, the formulas and divide it by from this one divided by the standard error, the coefficient divided by the standard error, and turn out to be the test statistic is 1.232. Okay, and which is just exactly from the table here. Birds is 1.232. Okay, so we have been up to step 3. I think the most complicated part is step 4. Step 4 is the decision rule. Then we have the critical value approach and p-value approach. So do it one by one. Critical value approach and p-value approach. So what's the critical value approach? We have to decide the critical value, right? What's the critical value? So first of all, let's know the degrees of freedom. We have 215 number of observations minus 4. So is 211. And if you check with our table, the table just provided all the critical values up to 120. Okay? So just use 120 if we check with the table. Okay? Because it won't matter that much. Okay? By the way, let me tell you that if you check with the table from our textbook, you all check with the table from textbook. Okay, if you see the table from the textbook, okay, let me explain something here. You can see the column, the first column, up to the degrees of freedom is 120. Then after that, did you see the other row, which shows the normal? And the degrees of freedom is infinitive. Okay, this means that the t distribution will be the same as standard normal distribution if we have many observations. If we have many observations, then the degrees of freedom is many. Therefore, in that case, you can check with the infinitive degrees of freedom, and did you see the numbers which is not quite different from the degrees of freedom with 120. Did you see that? Therefore, I'm saying that as long as you have the degrees of freedom which is 120, just use 120 because it won't matter that much. Okay? All right. So this is our test statistic, and we are working with the one-sided. Okay? So what's the critical value here? So it depends on the alpha level. Okay, so since I show here, just using one of the critical value, but you can, I'm using alpha is 5%. So I'm using this one, 165. Did you see that, my numbers? This is really, I check it from the computers. It's not from the tables. So if you see 120 for two sides is 1658. Okay? And I check with the computers, 165 to 11. You can just use 1.658. That'll be fine. It really matters. Okay? So in that case, let me draw the diagram here again to help all of you if it is useful. So I'm using, this is alpha equal to 5%. So checking with the table is 1.658, right? Okay. And this is 0. Okay? And what is your test statistic? Is 1.232, right? So where is it? Somewhere 1.232, huh? Yeah. Oh, I'm sorry. This one. Where is it? This is the rejection region, right? So where is it? Here. Do not rejection, non-rejection region, right? It's here. From this line, 1.658. And the number, our test statistic is 1.232. Okay? So it's smaller than this number, so falls on the non-rejection region. So critical value is always compare the test statistic with the critical value. And what's the p-value? P-value is the lower tail area of the test statistic. So what is the p-value? It's here. Look at my blue ink and my red ink. So alpha is my blue ink. Then red ink should be greater than alpha, right? Look at the diagram. And what is the p-value here? What's the area of this red ink? If we check it from the output, what is it? You have using, this is two-sided, right? Divided by 2. Remember to divide it by 2, since I'm working with one-sided test. So P, usually this is more professional way to do it. Since this is the lower tail, so this means that the probability of T, this is our test, greater than this sided 1.232, the probability. This is T. greater than 1.232. And according to the output, is using 0.2191 divided by 2. So 0.10955. Okay? Okay? So what's the p-value approach? Compare the p with alpha. So according my alpha is 5%. So is this one greater than 5%? Yes. So do not reject the null hypothesis. It all, from critical value approach, we know that it falls on the non-rejection region. If I use the p-value, it is greater than alpha level. Therefore, the conclusion is not reject. Do not reject the null hypothesis. Okay, so if okay, this is what I have to do. I have to say, do not reject null hypothesis. I think this is all, a common expression, and we always learn from what other people say, and also what they show, express, to make the conclusion. So if you do not reject the null hypothesis, what do you have to say? There is not enough evidence to infer. Always say the alternative hypothesis. I like all of you to learn how to express in this way. I like to say, I show it more clearly here. If I reject null hypothesis, okay, I will say there is enough evidence to infer beta, like this one, whatever beta, okay? And this one should be our alternative hypothesis. So in this case, beta 3 is greater than 0. If I reject, I have to say in this way. But actually, according to our test, hypothesis testing is do not reject, right? So I have to say, do not reject null hypothesis. Then what do I have to state my conclusions? There is not enough. Let me show the enough here. Evidence to infer beta 3 greater than 0. So see the difference. I say either reject or do not reject. Whatever put it here is all null hypothesis. And if I reject, there's enough evidence. If do not reject is not enough evidence, the rest of them are the same. This is the correct way to make the conclusions. Do not say that. Do not reject null hypothesis. There is enough evidence to say a null hypothesis is true. That's totally wrong, because when we do the hypothesis testing, the purpose is for alternative hypothesis. It's not for null hypothesis. So do not make conclusions for null hypothesis. Just reject or do not reject null hypothesis. and make all the conclusions from alternative. So if you are using alpha is 10%, in this case, I have the p-values even greater than alpha, although it's just a little bit greater, but still it's greater than p-value. So whatever alpha significance you are using, either 1%, 5%, and 10%, the result will be the same. Just do not reject the null hypothesis. Okay? Understand what I'm saying here? Is that clear? It is more clear after this practice? Okay, so far I already covered up to okay, up to 154 on our textbook, 5.3. Okay, and I will continue the two-sided test, because from two-sided test there is a third way to do it. So far, we're learning either one-sided test using alpha critical value approach, use critical value approach, or p-value approach. But if you are working with two-sided test, okay, that is did I put it here? Let me see. Okay, there's for two-sided test. Okay, I think this example is what we just have it from the Woody's example. Okay, from this Woody's example. This one we're working with two-sided test, right? And I have already shown p-value approach and critical value approach. Now I wanted to set it also for confidence interval approach, which is in our textbook 5.5. Okay? And in this way, okay, what do we mean by confidence approach? Okay, in order to do this one, I think I need to give me some downloaded. I have this one, Woody 3, okay. I have downloaded, okay, this time. Oh, I'm sorry. I want to use Excel. The reason I wanted to use Excel is because I can get those information from Excel. And I don't see that from eViews. So, you know, I really hope everybody know how to work with the Excel. I think I show you how to do the regression analysis from Excel file, right? So I'm working with this one using Excel, okay? And let me see. Oh. Do I have that? I don't have the data analysis. Okay, then I have to do this one. again. Okay. Okay, look at this one. This is the UDI 3's Excel file. Okay, and in order to do the regression analysis using Excel, I have to have a function called data analysis. Okay, I think I teach you how to do it, right? So after I have these functions, then I can click on this function and go inside the analysis tool, choosing regression analysis. Okay, and this is what I learned. I have to choose. This is regression. Okay, you can follow me as what I did. Okay. Okay. Then I'll tell the where is my y area from the UDIs 3. This one. Okay, this is my. I have to show my y variables, the area of my y variables, and all the x variables too. Okay, then I need to have labels, and I'm using confidence interval as a 95% since I'm using alpha as a 5%, right? Okay, in that case, then I will have the output like this. Okay, I'd like all of you to do this one using Excel by yourself and do as what I have until this output. Then I will show you where is the confidence interval approach information from Excel. Okay? Sorry, I need to. Okay. This is all right. Never mind. You all have this output? You know, it's really good to practice in the class. Otherwise, you will not remember what I did in the class. So if you learn it right now, it will save your time at home to review all the material. Yeah. Uh, 95. Confidence in level is 95. Is the 95. If you don't do that, I think default will be 95. Okay. This is from the Excel regression output. Now you can see all this coefficient, standard error, and up to the p-value. It's really exactly the same as the eViews, right? Okay, why don't we take a break for 10 minutes? Then I hope everybody have this result, something like Excel output, like what I did on the screen. Okay, and let's take a break.